we have seen the 8-point DFT. So sometimes they go in the problem, it will be specified how many point DFT we are supposed to find out. So here it has been given. So find the 4-point DFT of x of n. But here if you look into the sequence, 4-point DFT means the value of n will be equal to the 4. So but if you look into the sequence, the length of the sequence is having the 3, length 3, but we need to find out the 4-point DFT. So at that time what we can do is we can pad the 0 at the end of the sequence and we can make the length of the sequence is equal to the 4 we can make. So now let us write the formula for the DFT. So the DFT of the sequence is nothing but it's a x of k. It is equal to the x of this one. Let us write the let us find out the problem is find the 4-point DFT of x of n is equal to 1, 2, 1. The 4-point DFT means the value of the capital N is equal to the 4 we need to consider. So we need to find out the length of the sequence. So here the length of the sequence is 3, but here it is just good to find out the 4 DFT. So if the length is not equal to the value of n, we can pad 0 at the end of the sequence. So let us find out write the generalized formula for finding the DFT. It is x of k is equal to summation x of n into the power of kn. So here the k can take the value 0 is less than k is less than or equal to the n minus 1 it will take. Now let us substitute the value of the n is equal to 4, let us substitute. So it is equal to the summation n is equal to 0 to the n minus 4 minus 1 is 3. So x of n omega 4 to the power of k into n. So here k can take the value 0 is less than k is less than or equal to the 3 we can take. So here that is the value of the k will take. Now let us expand the summation. It has become x of 0. X of 0 is nothing but 1 plus for n is equal to 1 it will become so 2 into omega 4 to the power of k. For n is equal to 2 it will become so 1 into omega 4 to the power of 2 into k. K is equal to n is equal to 3 it will become it is 0 x of 3 is 0. So we'll get like this. So this is the formula we got and we need to find the twiddle factor values in order to find values for the DFT. So the twiddle factor values are important in order to expand the summation here. So here k can take the value 0 to the 3 it will take. Let us substitute the value for the twiddle factor. So it is omega 4 to the power of 0 is 1. Already we discussed in the previous sessions. Omega 4 to the power of 1 is minus j and similarly omega 4 to the power of 2 is minus 1 and similarly omega 4 to the power of 3 is equal to the omega 4 to the power of 3 is equal to the plus j we get here. So these are the values already we find in the last previous sessions. Let us substitute k is equal to 0, 1, 2, 3 and let k. So what we do is let us substitute k is equal to 0 in this expansion. So if you substitute k is equal to 0, k is equal to 0. So here k is a, here k is a, we can substitute as 0. So it has become 1 plus 2 plus 1 will get. So this is equal to the 4 will get. So similarly, let us substitute k is equal to the 1. So it will become x of 1 is equal to the, wherever k is a, we can substitute as 1. Omega 4 to the power of 1 plus omega 4 to the power of 2. Now let us substitute to the power of 1 which is minus j. The value is here. And omega 4 to the power of 2 is minus 1. So minus it will become the value will become equal to the 1 minus 2 into j will get. Next omega 4 to the power of 2 is minus 1. So it will become so minus 2j will get. So minus 1 will get cancelled with the plus 1. So the remaining value is minus 2j will get. So similarly, let us substitute k is equal to the 2. So it has become x of 2 is equal to 1 plus 2 into omega 4 to the power of 2. So we are substituting the value for k is equal to 2. So 2 into 2 will become 4. Omega 4 to the power of 4 is it's a 0, and omega 4 to the power of 2 is minus 1 here. So it will become 1 minus 2 plus 1. So it is equal to the 0 we get. 3. So it has become x of 3 is equal to the 1 plus omega 2 into omega 4 to the power of 3 plus 1 into omega 4 to the power of 6. So omega 4 to the power of 6 is the thing, but it is omega it has become equal to the it will become equal to the so 1 plus 2 into j plus omega 4 to the power of 6 is the omega 4 to the power of 2, it is minus 1. So we will get the 2j will get. So these are the values for the different values of k will get here. Now let us summarize the value for the x of k. So x of k is equal to the for k is equal to 0 it is 4, for k is equal to 1 it is minus 2j, for k is equal to 2, and for k is equal to 2 it is plus 2j. So this is the x of k we got for the x of n is equal to the 1 2 1 0. Now similarly, let us find out the IDFT of the sequence, that is inverse DFT. Let us find out here. So this inverse DFT we can find out by taking the inverse, considering the inverse DFT formula. Let us see how we can find out the inverse DFT. So we'll take the problem. So find the inverse DFT. Find the inverse DFT of x of k. So x of k is given. So it is 2 1 plus j, 0 and 1 minus j. So here the length of the sequence is 4. We can assume we need to find out the 4-point IDFT we need to find out. Let us assume the length of the sequence n is equal to 4. We can observe. By observation, we can find out the length here. So here in order to find out the inverse DFT formula, let us apply the write the generalized formula. So it is IDFT of x of k. So this is equal to x of n. So it is 1 by n summation. Here k can take the value 0 to the n minus 1. So it's a x of k into n to the power of minus k into n. So here n can take the value from 0 to the n minus 1 it will take. So here one of the important thing is that we need to find out the value for to the power of minus kn we need to find out here. So omega into the power of minus kn is the limit. It's a if you go in the reverse direction we'll get here, or we can apply the conjugate property we can apply here. So what we can do is, so first substitute n is equal to 4. I'll substitute here. Let us expand the formula. So it is 1 by 4 summation k is equal to 0 to the 3 x of k into omega 4 to the power of minus k into n. So here n can take the value from n is 0 to the 3 it will take. Now let us consider the find the values for the twiddle factor. So in order to find the value for the twiddle factor omega 4 to the power of minus kn, so we can consider the symmetry the conjugate property omega n to the power of minus a is equal to the, so it's omega n to the power of plus a, and if you take the conjugate of that one, omega n to the power of plus a, if you take the conjugate of that one, so where a can take the value from as usual 0 to the n minus 1 it will take here. So here we need to find the value for the twiddle factor, which is going to range from omega 4 to the power of 0, this is 1, and omega 4 to the power of minus 1, so it is equal to the omega 4 to the power plus 1, the conjugate. Omega 4 to the power plus 1 in the previous problem we have seen, so it's a minus j. If you take the conjugate of this one it will become plus j. So let me recall, in the previous problem we have seen here, so omega 4 to the power of 1 is minus j, omega 4 to the power of 2 is minus 1, omega 4 to the power of 3 is plus j. So let us take the conjugate of these values. Let us take the conjugate of these values. So here what we can do is, so omega 4 to the power of minus 2, so this is equal to the minus 1 conjugate So the conjugate is having effect on the imaginary terms. Since it's a real term, it does not have any effect. So it's a -1 only. Similarly, omega 4 to the power of -3 is equal to the, so omega 4 to the power plus 3 is j. When you take the conjugate, it will become equal to the minus j will get. Now we'll make use of these Twiddle factor values in this expansion, and let us find out the IDFT of the sequences. Let us find out. So here, if we expand the sequence by substituting the different values of k, by substituting the different values of k here, so it will become 1 by 4. So it will become 1 by 4 into, so if I substitute k is equal to 0, it has x of 0. For k is equal to 1, so it's a x of 1 into omega 4 to the power of. So here I'm expanding the summation with respect to the k is equal to 0 to 3, wherever k is there. So this k values we can do replace with the, these k values we can replace with the 0, 1, 2, 3. So it is omega 4 to the power of minus n, plus for k is equal to 2, it is x of 2 into omega 4 to the power of minus 2 into n. For k is equal to 3, it's a x of 3 into omega 4 to the power of minus 3 into n. So now let us substitute the value for the x of k for the different values. So it's a x of n. We can substitute the values for the x of k here. The x of k is here. So it's a 2, 1 plus j, 0 and 1 minus j. Let us substitute here. Substitute these values here in place of the x of k. So here it's a 1 by 4. X of 0 is, it is a 2 plus 1 plus j into omega 4 to the power of minus n. For x of 2 it is 0. For x of 3 it is 1 minus j into omega 4 to the power of minus 3n. So now we need to substitute the values for the n is equal to 0, 1, 2, 3, and we can find out the sequence. Now let us substitute n is equal to the 3 here. So n is equal to 0, 1, 2, 3. So if I substitute n is equal to 0, it has become x of 0 is equal to 1 by 4. When I substitute n is equal to 0, n is equal to 0. So omega 4 to the power of minus 3 and 0 is nothing but 1 only. So here omega 4 to the power of 0 is nothing but 1 only. So it will become 2 plus 1 plus j plus, so 1 minus j. So your minus j plus j will get cancelled. So the sum is 4 by 4. It will be equal to the 1 we'll get here. So similarly, let us substitute n is equal to 1. So it has become x of 1 is equal to 1 by 4. So wherever n is there, so here n is there, we can substitute as -1 plus, sorry, 1, and here n is there, we can substitute as 1 here. So it has become 1 plus j into omega 4 to the power of -1 plus 1 minus j into omega 4 to the power of -3. So let us substitute omega 4 to the power of -1 is j and omega 4 to the power of -3 is j. So if you substitute and simplify, so the value of this one will become equal to the 0 you will get here. So this will become equal to 0. So similarly, let us substitute n is equal to 2. So it has become x of 2 is equal to, so 1 plus 4 into 2 plus, so 1 plus j into omega 4 to the power of -2 plus 1 minus j into omega 4 to the power of -2. Omega 4 to the power of -6 is nothing but omega 4 to the power of -2. So if you simplify this one by substituting the values, so this will become equal to the value of this one will become equal to 0 will get. And similarly, if I substitute n is equal to 3, so it will become to 1 by 4 into 2 plus 1 plus j into omega 4 to the power of -3 plus 1 minus j into omega 4 to the power of minus, so 3 into n, so n value is 3, so it will become -9 will get. So if you apply the periodicity property, it is omega 4 to the power of -3, so this value will become equal to the, so 4 by 4 will get here, so it will become equal to 1 here. So therefore we can write the sequence x of n is equal to the, so it is 1 0 0 1 will get here. So this is the IDFT of the sequence. This is IDFT of the sequence x of n is equal to, so that is the, for the sequence x of k is equal to, so for this sequence the IDFT is, that is the x of n is equal to the 1 0 0 1. So the next